Good morning, everyone. Thank you for joining us today. In our last deep dive, we were really under the hood of the connected machine, right? We looked at the IoT, the cloud, the edge computing, all the hardware and architecture that makes modern automation tick. But today, we're pulling way back from the technical schematics to tackle something, well, something far more complex and frankly, a lot more important, the human element. We're going to dig into the social, the ethical, and the professional fallout of living in a world that's increasingly run by machines. You know, this quote right here, this is really the core idea for today. As these automated systems get smarter and weave themselves deeper into our lives, the biggest roadblocks we're hitting, they aren't technical bugs, they're human problems. We're talking about our changing place in the workforce, the massive challenge of securing our automated infrastructure, and maybe the biggest question of all, what are our moral responsibilities when we hand over life-altering decisions to an algorithm? So let's just dive right in. Okay, so here's our game plan. We're going to start with the personal stuff, how automation is changing our jobs, and the skills we actually need to succeed. Then we'll zoom out to the big picture, the systemic threats, looking at the huge cybersecurity risks that pop up when you connect the physical world to the internet. And finally, we'll get a little philosophical and wrestle with some of the really deep ethical questions that AI forces us to confront. It's a big journey, but an essential one. Right. Let's kick things off with something that hits close to home for pretty much everyone, our jobs. Automation is said to completely shake up the workplace, and that, of course, raises some really fundamental questions about what work is even going to look like. What do our careers become in a world where machines can do so much of what we used to do? What does that mean for the relationship between companies and their people? Let's unpack that. When you hear people talk about this, it can get really polarized fast. It feels like it boils down to one of two camps. Either it's this utopian dream of a work-free future, or it's a dystopian nightmare of mass unemployment. But as always, the reality is it's a lot more complicated than that. So let's break down the three big ways people are looking at this debate. So on one side, you have the displacement story. This is that gut-level fear of mass unemployment. And look, it's not coming from nowhere. We saw it happen with industrial robots on the automotive assembly lines in the Rust Belt. Repetitive tasks like welding got automated, and it just hollowed out a huge part of the manual labor workforce. But then you have the other side, the creation story. This is based on this classic economic idea of creative destruction. The argument is, sure, technology kills old jobs, but it always creates new, often better jobs to replace them. Think about the automobile. It definitely put a lot of blacksmiths out of work, but it created millions of new jobs in manufacturing, highway construction, gas stations, motels, the entire service economy that sprang up around it. But here's the thing. It's not really a simple choice between jobs being lost or jobs being created. The reality, the thing that's actually happening is transformation. For the vast majority of us, our jobs aren't just going to disappear. They're going to be redesigned. Automation is going to take over the routine, the repetitive, the data crunching parts of our day. And that frees us up. It frees up human beings to focus on what we do best. A perfect example is a radiologist. An AI can now scan thousands of medical images way faster than a person, flagging potential tumors with incredible accuracy. But it can't do what the human radiologist does. It can't interpret a really weird, novel case, or more importantly, sit down with a patient and explain a difficult diagnosis with actual empathy. The job isn't gone. It's been elevated. And that's an exciting idea. So if we accept this idea of transformation, it immediately leads to the next big question, right? If the machines are handling all the routine work, what's left for us? What are those uniquely human skills that are going to become not just valuable, but absolutely essential in this new world? Well, the answer seems to fall into three main buckets, three areas where humans still have a massive edge over machines. First, you've got higher-order cognitive skills, things like critical thinking, creative problem solving. Second, social and emotional intelligence, leadership, teamwork, empathy. You know, a cobot in a hospital can help a nurse lift a patient, sure, but it can't provide that emotional support that is so central to healing. And third, and this is a big one, is technological literacy. Now, this doesn't mean everyone has to become a hardcore programmer, but having a basic fluency, understanding how to work with and alongside these smart systems, that's quickly becoming non-negotiable. These are the skills that don't compete with automation. They complement it. Okay, but here's the catch. This whole transformation is creating a huge skills gap. The skills that are suddenly in high demand are not the skills that a lot of the current workforce has. And closing that gap, it's not on any one group. It's a shared responsibility. Governments have to step up and reform education, fund new training programs. Corporations need to stop seeing reskilling as just a cost and start seeing it as a critical investment in their own future. And for us as individuals, we have to fully embrace this idea of being lifelong learners. The ground is shifting under our feet, and we have to be willing to shift with it. All right, so we've talked about the challenges and the opportunities for us as individuals. But now we need to zoom out and look at the bigger picture. What are the systemic risks we need to have on our radar? And in this next section, we're going to tackle one of the biggest, cybersecurity. Because as we connect more and more of our physical infrastructure, our factories, our power grids, to the internet, we are opening up a whole new world of vulnerabilities. Let's take a closer look. For decades, the systems that control physical things, think factories, power plants, what we call operational technology, or OT, were kept completely separate from the corporate office networks, the IT world. This separation was called the air gap. It was a literal physical gap. The networks didn't touch. But now, thanks to things like the industrial Internet of Things, we've torn that wall down. We're connecting our industrial machinery to IT networks so we can get all that juicy data for analysis and do remote maintenance. It's incredibly efficient, but it also creates a direct digital highway for an attacker to go from hacking an employee's email straight to the controls of a robotic arm on a factory floor. And this is where things get really, really serious, because the entire philosophy of security is different in these two worlds. In IT security, we're all about protecting data. The mantra is confidentiality, integrity, availability, in that order. But in the OT world, you're protecting physical processes. A data breach is bad. But a hacked pipeline or a compromised power grid, that's a whole other level of crisis. The priorities are flipped upside down. Safety and availability are everything. The stakes are just so much higher when physical systems are on a line. And if you think this is all just theory, let me tell you the story of Stuxnet. This was back in 2010. Stuxnet was a piece of malware so advanced, it's widely considered the world's first true digital weapon. It was allegedly designed to sabotage Iran's nuclear program, and it worked by jumping that IT-OT air gap to target the industrial controllers running their uranium enrichment centrifuges. It didn't just crash them, it subtly changed their programming, causing them to spin out of control and tear themselves apart, all while it was feeding fake everything's normal data back to the engineers. It was a terrifying masterpiece, and it proved once and for all that code could be used to cause targeted physical destruction in the real world. And it's not just sophisticated nation-states we need to worry about. Fast forward to 2021 and the Colonial Pipeline ransomware attack. This was a criminal group, not a government, and they hit the company's IT billing systems. But because those systems were connected to the operational side, the company panicked and shut down the entire physical pipeline, a pipeline that supplies nearly half the fuel for the U.S. East Coast. It was a massive wake-up call that showed just how tightly coupled our IT and OT worlds have become, and it brought the threat home for millions of people who were suddenly waiting in massive lines just to get gas. So, how in the world do we defend against this? The answer is a strategy that security pros call defense in depth. It's not about finding one magic bullet. It's about creating layers of security. It means things like network segmentation to rebuild some of those digital walls, using special monitoring tools that actually understand industrial protocols, and deploying endpoint security on the industrial devices themselves. It's a complex, layered approach, but it's the only proven way to start managing these risks and keep our critical infrastructure safe. Okay, this brings us to our final and maybe the most profound part of our discussion. We've talked about jobs, we've talked about security. Now we have to stare directly into the ethical labyrinth that we create when we build systems that can learn and make decisions on their own with very real consequences for human lives. Let's start with one of the most fundamental ethical risks we're seeing right now, algorithmic bias. You have to remember, an AI system knows nothing about the world except for the data we give it to learn from. So what happens when that data is a perfect reflection of all of our own historical biases and prejudices as a society? Let's look at a real-world case, automated hiring tools. Companies use these to sift through thousands of resumes more efficiently. But imagine you train this AI on your company's hiring data from the past 20 years. If, historically, your company has hired more men for engineering roles, the AI learns to associate male characteristics on a resume with success. It's not evil, it's just pattern matching. But the result is that the system starts to systematically downgrade perfectly qualified female candidates, entrenching past discrimination under this shiny new veneer of objective technology. It's a perfect example of how AI can accidentally amplify our worst tendencies. And that leads to another huge problem, what I call the responsibility gap. When a human driver makes a mistake and causes an accident, we have centuries of legal precedent to figure out who's at fault. But what happens when a self-driving car causes a fatal crash? Who's legally or morally responsible? Is it the person in the driver's seat? Is it the car manufacturer? Is it the specific engineer who wrote the piece of code that failed? It's a complete legal and ethical minefield, and it's a huge unanswered question as we race towards this autonomous future. And now we get to the most charged debate in this whole space: lethal autonomous weapons, or laws. Some people call them killer robots. These are weapon systems that could independently decide to use lethal force without a human in the loop. The people who argue for them say they could be more precise than human soldiers, reducing civilian casualties and protecting our own troops. But the arguments against are powerful. Opponents say a machine can't possibly make the nuanced, ethical judgments required by the laws of war. There's no accountability. And fundamentally, they argue that delegating the decision to take a human life to an algorithm is just an affront to human dignity, a moral line we should never cross. This isn't science fiction. This debate is happening in the halls of the UN right now. The stakes just couldn't be higher. So, as we bring all these threads together, the jobs, the security, the ethics, it becomes incredibly clear. The hardest problems in automation aren't hiding in a line of code or mechanical gear. The real challenges are human challenges. They're found in our social structures, our security planning, and our moral compass. So what do we take away from all this? First, the future of work is not about man versus machine. It's man and machine. And making that work is going to require a massive, all-hands-on-deck commitment to reskilling and lifelong learning. Second, as we connect our physical world to the digital one, we have got to be obsessed with cybersecurity. The threat is real, but it's manageable if we invest and focus. And finally, and most importantly, we have to have a serious, grown-up conversation about the ethics of AI, and we have to have it now. We need to be intentional about building a future where this incredibly powerful technology actually serves our shared human values. Tune in next time as we explore the next generation soft swarming and biohybrid robots. Thank you for joining us today, and we invite you to subscribe to our channel, Tech, AI, and Beyond. You know, as we move forward, as we build this incredible automated world piece by piece, this is the one question we have to keep asking ourselves over and over again. Are we just building something that's smarter, or are we building it with wisdom? I'll leave you with that thought. Thanks for joining me.